Hello, good evening, everyone. So today we are going to discuss this solve the session with speaking art. So PDF was shared with you. Do you guys have any doubt there? And we will start uh, first with that. Have you guys solved these questions in PDF? Okay, so we will discuss every questions one by one. Okay? So here is the first question. Says x1, x2 are x1 to xn are some IID samples, independent and identically distributed from a distribution X with mean mu and standard deviation sigma. Where mu hat is one estimator of mu, then find the risk of mu hat estimated. So, will you guys try to solve this question? Okay, done. Like we have discussed how to calculate this risk of an estimator. For that, uh, so what information we have here is given that mu hat is equal to 20 times x1 plus x2 plus all so on till xn divided by n, right? And we are checking risk of mu hat is our question, right? So for risk of mu hat, that is, we represent that risk of mu hat is equal to what? Expectation of mu hat minus mu dot square. Uh, that is nothing but the, if I convert this into this biasness formula, then it will become nothing but the biasedness of mu hat minus mu plus variance of mu hat, isn't it? Like how did we say that? The similar format for that we use for expectation of x square. We write it as the expectation of x the whole square plus variance of u. Sorry, square here. Fine. So what will be expectation of mu hat, like I think we are going to get the biased ness of mu hat. That will be expectation of mu hat minus u. Fine. What is expectation of mu hat? That is nothing but expectation of 20 times x1 plus xn divided by n. Okay. Minus u. So once we solve this, we'll get to know that 20 by n is constant. Then these are n random variables and expectation of xi is given to us. It is equal to mu. So again, for x1 to xn, it will be n times mu minus mu. So, and then we'll get cancel and remaining will be 19. Fine. And what will be variance of mu hat? That is nothing but variance of 20 by n x1 to xn. Again, we know that these xi's are independent and identically distributed. So I will just bring out this constant as a square of them and summation of variance of xi's, right? So next we will xn. So variance of xn is given as sigma square. So variance of x is equal to sigma square, and there are n independent random variables. So we can have it as a 400 n square times n into sigma square. So that will turn out to be 400 sigma square upon n. Fine. So from there, risk of our estimator mu hat is given as bias of mu hat and mu square plus variance of mu hat. So bias we have calculated, it was 19 mu. So that will give us 19 mu square plus this one is 400 by n, n sigma square. Fine. So once we square it, will be 361 mu square plus 400 by n sigma square. So that will be our risk for the given estimator. Okay. So any doubt here?
No, ma'am.
Okay. So just tell me if you guys have solved this PDF, then we can discuss other doubts also. Okay. So that's all. Then there is another question which tells about like if Xi's are IID samples where X is a random variable with density function. The sample from this distribution is taken. What is the maximum likelihood estimate of theta for the sample. So we discussed yesterday only how to find out the maximum likelihood estimator, right? So whenever we are going to calculate or find maximum likelihood estimation, what is our requirement? We need density function of the random variable. So it is given to us, and then some sampling is also given to us. So we'll take care of the sampling later on. First, we will find estimation for theta. So what will be our procedure to solve this question? Do anyone remember?
We will do differentiation.
But differentiation of what?
We'll find out the likelihood function first by multiplying
All the density function, yes. Then
and then we'll differentiate it with respect to the parameters.
okay. So I'm just waiting for 2 minutes. You just try it if you are able to do it. And then we will have some like first we will form a likelihood function by multiplying all the density function. Then what we'll do? Our task is to maximize this function. So instead of maximizing L, we will convert it to log likelihood function and then differentiate it with respect to theta, as theta is parameter here, and then equate it to 0. It will give us some value for theta, that is estimation for theta. Then we will put the sampling values for that, and accordingly we get this maximum likelihood estimator for this particular sample. Okay, let's check how to solve this. So nothing new there. We have to just first find the likelihood function for that. That is nothing but L of x1, x2 to xn, and that is equal to product of I t product fx of xi, right? Of xi. I from 1 to n. So what is density function given to us? It is theta upon x power theta plus f. Okay. So if we multiply it, what will get? This theta is a constant kind of term there, so it will be
Theta power
theta power m, and the rest of the terms will be like May I write it as a xi raised to x1 raised to the power minus theta plus 1, right? Into x2 raised to the power minus theta plus 1. Sorry, yeah, like that, right? And so on. Some multiplication. Fine. If you are comfortable with denominator, that's also fine. Theta plus 1. Okay, 1 is good. Right? Like that it is given there. Is it fine? Or it will be like a product I is equal to 1 to n theta into xi raised to the power minus of theta plus 1. Okay. So we'll just put all the i's there. So it will product. So now you can't sum up all this, right? All this power. Why? Because base is not same. So what will be our next target? As to differentiate this function with respect to theta will be more complicated. So we will just take log likelihood, that means log on both sides. So log of L will be what? Yeah, logarithm of these things. What will we get if we apply log on this term? Theta raised to the power n into x1 minus of theta plus 1 into x2 raised to the power minus of theta plus 1 and so on. So the very easiest task we can do with the logarithm is just first multiply, like multiplication will get converted into addition, right? So it will be log of theta raised to the power n plus what? Log of x1 raised to the power minus theta plus 1 and so on. Fine. And then, yeah, if these are the powers of terms, so it will be nothing but n log theta. Then it will be minus of theta plus 1 log of x1 and so on. Okay, minus of theta plus 1 into log of xn. Okay. So one more thing you can notice that this theta plus 1 is constant everywhere. So is it fine if I keep it out constant there? Yeah, minus what will be there? Minus theta plus 1 constant and rest of the terms will be log of x1 plus log of x2 and so on. Why I have done this? Because we have to differentiate our function with respect to theta. Because we are maximizing this function for theta, right? So differentiating log L with respect to theta and equal to 0. Zero. That implies what? Derivative of log L with respect to d theta is equal to 0, right? That will give us, yeah, derivative of which function? This one. N log theta minus theta plus 1 times log of x1 till log of xn. And that is equal to 0. So what will be the differentiation of n log theta? N is constant and differentiation of log theta is 1 upon theta. Fine. Then minus of theta plus 1. Now, what will you do for that? So minus of theta plus 1 is what? 1, right? When you differentiate
Yes, ma'am. 1 minus 1.
theta plus 1 will be equal to 1 plus 0, right? Derivative of theta will be 1, derivative of constant is 0. So it is 1 and rest of the part is just a constant thing. So we will write it as it is, log of xn, and that will be equal to 0. So we'll do one more thing here. We'll transfer this, write this theta as theta cap just to represent that this is estimate, or you can just put cap at the end. So that implies your value for theta, estimation for theta is nothing but what? N upon log of x1 plus log of x2 till log of xn. So this is what our estimation for theta for the given distribution of a random variable x. Okay. So the parameter estimation for theta, it is given to us. Now, there is some sample also was given to us. The sample was taking some values as 3, 6, 2, 7, 8, and 10. So these are the values of what? This sampling is given to us. But these are the values of what?
Xi, ma'am.
Yeah, these are the values of xi. So what will be our n then?
1, 2, 3, 4, 5, 6, ma'am.
Yeah, our n will be 6. And just will take the log of each number and add them. That's it. That's our solution. Log 3 plus log 6, log 2, and all these things, plus log 8 plus log 10. That's it. Once we calculate all this value, and it will give you some values around 0.60. So that is the estimated value for theta hat for the given sampling. Okay. That's it.
How you find the log of a specific value?
You will be provided with the calculator. Yeah.
Okay, okay.
So you can put the values there. And
Hmm. Okay.
okay. So any doubt in this particular question?
No, ma'am.
Yeah. Anyone else?
Ma'am, can we do this without applying log also?
Actually not. It will be very tricky. If you do not apply log, then see this part. So just
Ma'am, because this question, if we don't apply log, even then it is not that complicated, ma'am. And but we are getting a different answer if we do that.
from here.
Yeah, ma'am. After that else step, if we do not apply log and if we do it directly, we are getting
You are getting what?
n by n minus 1.
How? If you differentiate this with respect to theta, how have you differentiated it? This is theta raised to the power n, and this is like you have to use product rule, right?
Yes, ma'am.
And this is a raised to the power theta. So what's the differentiation for that? A power theta into log theta, log a, right?
Yes, ma'am.
Okay. And then what are you getting there?
I guess I have a small calculation error. Sorry.
Yeah, because it's a like product rule and that's too big. And yeah, calculation will be
Yes.
tricky for that without log, because these are in the multiplication. They have to use product rule again and again, and then you will end up with the solution. And whatever the mathematical tool you use, your answer should be the same. You will come up with that the same answer if your calculation, all the calculations are the same. Okay. So should we move to the next question? Okay. So then question number 3. It says that x1 to x1, x2, x3, x4 are IID binomial sample. Value of n is 4 and p. Given a random sample, find the maximum likelihood estimate of p. So from this question, Can you just tell me what's your parameter here?
P, ma'am.
P. In
P.
generally binomial distribution, we have two parameters, n and p, right? But n is given to us. No, sorry, yeah.
Yes, ma'am.
N is given to us and p is there. So let's calculate the maximum likelihood estimator for p. So the same procedure, we know the density function of binomial distribution. Just multiply it 4 times because we have only 4 random variables here. And then take the log function and then differentiate it with respect to p equal to 0. That's it. So let's start the solution. So what is the distribution for binomial distribution? Binomial 4 comma p. So yeah,
NCR, ma'am. NCR p to the power r into 1 minus p to the power n minus r.
p power r into 1 minus p as to the power n minus
N
r.
minus r.
Okay. But n, we have the value of n here. So
4.
I will just replace, n with 4. So that's our fx of x. And again, I have used x here. So I will replace this all r with x. Fine. So function in x, right? This one. That's it. 4 minus x. Okay, fine. So this is our distribution function. So what will be the likelihood function? Yeah. L of x1, x2, x4, x3, x4, right? Generally, we write this colon with p also, either in at the initial or at the end, or it's understood something. Okay. That will be a product for 4 times 1 to 4 fxi of x. Okay. Then we can just substitute the values also directly because that is also easy to deal with as we have a sample also, right? 2043. But let's take it as directly. So product equal to 4c times p raised to the power x, 1 minus p raised to the power x. Sorry, n minus 4 minus. Then we'll take log. So again, and 4cxi is a constant term, we will take it outside, but the product of, right? So as we have the values of the sample, right? Sampling values are 2043. What does it mean there? This is value taken by x1, this is x2, right? x3, x4, isn't it? So we can take we can convert this generalized likelihood function into a what we say particular 2, 0, 4, 3 should be equal to, and now substitute the values there. Even though we can do directly also, there is no problem with that also. Okay. So do you want me to do directly or by substituting the values?
Directly.
Substituting the
If you want to see how to do directly, then in generalized form, see this is product I is equal to 1 to 4, 4cxi. This will remain as it is. There is no change. And p raised to the power xi, right? How will, if you multiply it p raised to the power x1, p raised to the power x2, p raised to the power x3, and p to the power x4, right? Similarly, what will be there? 1 minus p raised to the power 4 minus x1. So we can do one thing here. Can I write it as a summation of xi's, p raised to the power? Is it fine if I write it as summation of xi and 1 minus p raised to the power summation of 4 minus xi? Is it fine? 1, 2, 4. Is it so? Right? Then just take log on both sides. So what will get? If we take log L, then that will be log of all the sums. Log of what product I is equal to 1 to 4 cx, sorry, 4 cxi. We'll separate it out again, no problem. And addition of log of p raised to the power summation xi. Did you get how did I write the summation xi? Because base was same, so I just put the addition over. This is 1 minus p raised to the power summation 4 minus xi. I is 1 to 4 here. Okay, then this one. So that's nothing but log of 4c x1 plus log of 4c x2. This will give some number, right? When we put the values. Log of 4c x3, log of 4c x4, and then what about the next values? This one plus summation I is equal to 1 to 4 xi log of p. Did you notice one thing? What we are going to do next? So this term is almost going to be 0, right? What's our next step after writing the log L? We'll differentiate it with respect to p, and in that case, this constant term will all this constant term will be vanished, right? So even though you can skip that portion at the initial also, like log of 1 minus p. Now, once you find out the log likelihood function, to maximize this function, what we will do? We will do differentiating it with respect to p and equating it to 0. So when you differentiate this equation with respect to p, this will become 0 because it's a constant term. Again, this will be 0, 0, 0. So what will be there? Lies with this term. So constant outside, summation I is equal to 1 to 4 xi. Log p, differentiation of log p is 1 by p, right? So we can have it as this divided by p plus, again, this summation outside 4 minus xi log of 1 minus p, that is nothing but 1 upon 1 minus p into minus 1, which is equal to 0. Then next, what will get? That implies summation I is equal to 1 to 4 xi upon p is equal to summation I is equal to 1 to 4 minus xi upon 1 minus p. Fine. Now to find the value of p, what will do? Just multiply it, right? This and all these things will be like 1 minus p summation of xi, which is equal to p times summation of 4 minus xi, where I is ranging from 1 to 4, 1 to 4. Okay. Then, take the all terms together. So, 1 minus p summation of xi upon 4 minus xi upon 1 minus p. Fine. Now, take the all terms together. So, will be like summation xi 1 to 4, which is equal to p. Okay, p common out here. This term I am sending there, so it will be in addition 4 minus xi will be 1 to 4. Okay, let me just write it. P into summation xi. Okay, is it fine if I write like that? I just splitted the term. That's it. And then send P there. Okay. Then what's next? This is summation 1 to 4 xi, which is equal to P again common. And what will be there? It's summation there. 1 to 4, 4 minus xi plus summation I is equal to 1 to 4 xi. Okay. So we can delete this summation xi, right? What will be there then? So if you split the summation sign over here, this is nothing but 4 constant, then summation I is equal to 1 to 4, that is 1 plus 2 plus. Is it a 4? Sorry, it's a 4. 4 times 4 minus summation xi is equal to 1 to 4 plus again summation xi I is equal to 1 to 4. Just cancel it. So p hat is nothing but summation of I is equal to 1 to 4 xi upon 4 4s are 16. So this should be equal to x1 plus x2 plus x3 plus x4 upon 16. So just take it, just put log values. We have sampling values as 2.
Ma'am, 16, ma'am.
Yeah.
16, ma'am.
Oh,
You
yeah.
write it 14.
Okay, 14. Sorry. So 2, 0, 4, and 3. Just put all this value here, and then we will get p hat is equal to what's there? 2 plus 0 plus 4 plus 3. So 7 plus 2, 9 by 16, right? So 9 by 16, that is what our estimated value for this sampling for probably for p hat, right? So do you understand what we did here? So whenever we solve in general, that gives you one confidence that whatever the values are there, you will be able to do that. So note one thing there. Whenever there are constant terms like this, you are very sure that this will end up with the constant terms, right? So remember that in maximum likelihood function, later on we are going to differentiate the function with respect to our parameter. So if parameter is not there in that particular term, you can cancel it out. Okay, you can skip that term from that side on. So I have skipped it here just to show that there is uh, nothing there. If you differentiate it with respect to p, the terms are going to be 0. Okay. Okay, understood? What have we done in this particular question?
Yes.
Okay. So let's check with that. Another one. Okay, so there is solution also given to you. Now, there is a question number 4. It says that consider a sample of IID random samples, random variables x1 to xn, where n is greater than 30. Expectation of x size is mu, and variance is given as sigma square. And the estimator of mu is also given to us. Find the biasness of mu head. So can you do that? This question? Will you try? You have to take biasness of parameter mu. How to do that? Just expectation of mu n minus mu, right? So the estimation for new hat is given to us. New n hat is what? 1 upon n minus 1 upon n minus 30 summation of xi 1 to n. Okay. So just calculate expectation of new n hat. If it is equal to new, then it's a biased or unbiased. What if we calculate expectation of new and hat and it end up with new? Then what will you predict there?
Unbiased.
This is unbiased. Okay. So let's just check expectation of 1 upon n minus 30 summation I is equal to 1 to n example. Okay. So again 1 upon n minus 30 is constant, so take it outside. And inside there is summation of, so I can write it x1 plus x2 plus so on. It is given that these xi's are independent and identically distributed. So I can have it as n minus 30 times n into expectation of x, right? Or x1 because all are the identically distributed. So 1 upon n minus 30 into n into what expectation of x was given to us, right? It was new. Okay, there is one mistake, sorry. I is not 1 to n, it is given as 31 to n. Just check with the question. It is I is equal to 31 to n. If it is 31 to n, then what will happen? So it will be 31, 32 till n, right?
N minus 31, ma'am.
N minus 31 or what? Will be, yeah. How many terms are there? Now, if we have x1 to xn terms and this is x31 to x32 to n, so how many terms are there?
N minus 30, ma'am. N minus 30.
N minus 30, right? Okay, so that's it. N minus 30. Okay, this will get cancelled and this is going to be converted as expectation of. So you can just write instead of x1, just write x, that's also fine. Or you can write x also, x1 also, that is also fine because they are identically distributed. So expectation of x and that is given as new. So we got that expectation of estimator is nothing but new itself. That means it is an unbiased estimator, right? So bias of new and head and new will be equal to what? It is 0 directly, but we can have it like this, right? And it is equal to fine. Okay, let's take next question. Question number 5. Suppose it is known that a sample consisting of values 15, 16, 10, 8, 7, 9, 20, and 19 comes to our population with density function. Okay, density function is given to us. And again, maximum likelihood estimate for x. The same procedure, right? Just try it.
This is exponential function, no?
Yes, exponential function.
With lambda is equal to 1 upon theta.
Yeah. So for that you can use directly also, right? Yesterday only we have calculated what is the maximum likelihood for estimator for lambda. If you have decoded that it's a lambda is equal to 1 by theta, you can directly use that also. Do you remember that what was the estimation at that time? Okay, so let's start this solution. What estimation did you get by the way? Have you tried it? So yeah, it is a exponential distribution. So directly also, if you remember that lambda was nothing but n
N
upon
upon
summation of
N upon summation of all this.
summation of xi. So here what will be theta? If your lambda is equal to 1 by theta, that means your theta will be summation of xi upon n. That's it, right? But let's take with the this this method that are we getting the same answer? Right? X1, x2, xn. That is equal to what? Product 1 to n fx of x. So what is our density function there? 1 by theta exponential raised to the power minus xi by theta. Okay. So what will be the product then? So if in the exponential function, if we apply the product, what it gets converted into what? Summation, right? Minus x1 by theta to e to the power minus x2 by theta, and so on. Minus x1 by theta. So that is nothing but theta raised to the power minus n exponential summation xi upon theta, right? Minus. This is going to n. Okay. So now again the same procedure, take the log on both sides. So what will get log of L will be log of theta raised to the power minus n into exponential raised to the power minus summation xi by theta. Okay. So that is nothing but minus n log of theta minus summation xi by theta into log of e is 1, right? So yeah, yesterday we discussed that if it is a negative sign, we will do what? Instead of maximizing, we will minimize the function, which is similar to the maximization of positive f of x. So differentiating it with respect to theta and equate it to 0. So that we will get the minimized value of theta. So that will be d by theta of minus summation xi upon theta. Equal to 0. Log theta, what is the differentiation then? Minus n constant log theta, that means 1 upon theta. Now, again, summation xi, a constant thing. And what is the differentiation for 1 by theta then? 1 by minus 1 upon theta square, right? That is equating to 0. And minus minus plus, so it is n by theta plus summation of xi upon theta square. So once we solve it, it is nothing but n by theta is equal to summation of xi upon theta square. So that gives us theta hat is equal to summation I is equal to 1 to n xi upon n. Okay, that's it. Now we have sample values, sampling values for that, right? So we will put all these values of xi and sum them divided by n. What are the values given to us? It is 15, 16, 10, 8, 7, 9, 20, and 19. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so n is 8, and so we will add all these terms and divide it by 8, which will give us something what? Let's just do it. So that will be our estimation for theta hat for the given sample. Okay, that's it. Divided by 8. 31, 41.
104, ma'am.
Okay, 104. Okay, 104 by 8. Okay. So it's okay, divisible. 1, 3. Okay, that's sorry, 1, 3. That is all about what estimation of this theta height. Okay, understood? Any doubt here? So it since it was the last question, let me just check. Yeah, this is the last question. Any doubt here? Or any other questions you have, then we can discuss that. That was a session for Solving today for week 9. If you guys have any other doubts, we can discuss that, and yeah, please tell me.
Ma'am, is this PDF uploaded?
Yeah, it was uploaded yesterday only. That's why initially I asked you if you have checked this PDF, then what are the questions that we can discuss today. But it seems as today is the last date for graded assignment, right? So that's why we uploaded it early. Yeah. Any other questions?
No, ma'am.
Okay. Okay then.
No, ma'am.
Okay. See you then. Thank you for today.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
Thank you, ma'am.
Thank you.